All right, let's dive into section 3 where we will compare the IT and OT network design. Why do the comparison? Because once through the comparison, we will learn how the OT design, OT network design, and OT landscape looks like, and how information flows in an OT world. So first, we will discuss about the IT landscape, IT network, IT design, how information flows in an IT network, and then we will move on to OT. Let's get started then. Now, this is how the network of a typical IT/OT converged organization looks today. You will notice it's not just IT or just OT anymore. It's a mesh where both IT and OT devices are tightly integrated and often connected through the same network. You might find business servers, email systems, and cloud services sitting right next to PLCs, HMIs, or SCADA servers. That's a very common scenario in the taking into consideration the smart factory and industry 4.0 revolution. Now, as an OT security professional, your very first responsibility in such an environment is to understand the network, to mentally and on paper separate the IT enterprise layer from the OT process layer. If you leave this network flat like this, any threat that compromises the IT side, like ransomware or phishing, can very easily spill over onto the OT side and impact physical operation. So, segmentation builds that safety barrier, ensuring that IT risks don't immediately translate into OT disruptions. So, how do we start approaching this segmentation? The first step is to understand what a typical IT network looks like, what a typical OT network looks like, its design, its communication flows, and the type of devices that exist there and the communication traffic that they initiate. Once we are clear about the IT OT landscape, once we are clear about how the IT and OT network design looks like, how the information in a hierarchical manner flows in an IT and in an OT network design, then this comparison will give us the foundation we need to design effective network segmentation strategies that we will study later in this course. So with that, then let's first start by looking at IT network design and the information flow in a typical IT network. So before we dive into OT network design, let's first build a quick foundation by looking at how things work on the IT side, because understanding how data moves in IT networks will give us a solid reference point for understanding how control and information flow in OT networks later. So for reference point in the IT side, we are going to use the OSI model. We are all familiar with the OSI model. OSI model is one of the best ways to visualize how data travels between systems in the IT networks. So in brief, the OSI model, it breaks network communication into 7 conceptual layers, making it much easier to see where different protocols and devices fit in the IT network. So talking about the OSI model, then at the bottom, we have this physical layer. So we know that this is where your cables, Wi-Fi, and physical hardware like hubs would exist. And this is all about physical transformation of electrical or wireless signals. Then comes the data link layer. So you know this is where your Ethernet operates, where your network switches, they make decisions based on MAC addresses. Above that is the network layer. That's the layer 3 where routers and IP come into play. So this layer decides the best path for packets to travel across different networks. Then you have the transport layer. This layer focuses on data delivery, deciding which protocols to use. And then the session layer that manages and maintains sessions between systems. Then you have the presentation layer that takes care of how data is represented, that is handling encryption, compression, or formats such as TLS, JPEG, or PNG. And then finally, at the top, we have the application layer. This is where user-facing protocols like HTTP and SMTP operate. So overall, we can say that the OSI model, it gives us a clear, structured way to visualize how data moves across an IT network, from the physical wire all the way up to the applications that we use every day. So now let's look at how this compares on the OT side in industrial environment. What kind of model we will use there to slice down the complex OT environment, OT landscape, to understand where the devices, protocols, and equipments would fit in on the OT side. So now on the OT side, let's see how control and information flows through different layers of the automation hierarchy. And for that, we will use the Purdue model, which is one of the most widely referenced frameworks in industrial control system design and security. So the Purdue model, it organizes industrial networks into these multiple levels, right from the physical process at the bottom to the enterprise systems at the top. So let's look at these levels one by one. So at level 0, we have the process layer. This is where the physical action happens. You will find devices here such as sensors, actuators, pumps, motors, and valves. All those devices that are interacting directly with the physical process, those will come here. Then moving up to level 1, you will have the basic control layer. So we have PLCs and RTUs here. These devices act as the brains. They execute logic, send control commands to field devices, and receive process data back from them. So you will find connections here using serial links, vendor-specific interfaces, or industrial Ethernet protocols as well, such as Profinet, Modbus TCP, or Ethernet IP. And we will talk about protocols much in detail in section 8. Then at level 2, you have the supervisory layer. We find SCADA systems, HMIs, and engineering workstations here. So this is where operators monitor, visualize, and control plant operations in real time. Above that is the level 3, the site operations level, where systems like MES live. So these handle production planning, workflow, quality, and efficiency. So connecting real-time control data with the business logic. Then next to come the level 4 and 5, the enterprise layer. So this will include systems like ERP systems and some other business applications. So basically these systems, they focus on corporate level planning, logistic, and finance, and they don't communicate directly with the PLCs or SCADA. Information to this level, it comes usually through the MES or demilitarized zone for security, which we will talk about in detail on the next slide. And then you also have something called the independent safety layer. Now, this is the layer where your safety instrumented systems, they operate separately to ensure process safety even if the main control system fails. So in OT, we know that safety is the priority. So that is the reason this layer, it operates separately from the main control system. So the key difference between the two models that we saw, that is the OSI model and the Purdue model. The OSI model, it focuses on how data moves horizontally between peers in IT networks, whereas the Purdue model, it shows how control commands and process information flow vertically through an industrial system. So things like control commands, they flow downward from enterprise or supervisory layers down to controllers and field devices, and process data and feedback information, it flows upward. That is from sensors and controllers up to MES and ERP systems. So we can say that while OSI simplifies data communication, the Purdue model, it simplifies the hierarchy of control and information flow in industrial networks. So to summarize then, the OSI model explained you how data moves across IT systems, and the Purdue model explained you how control and information flow through OT systems. The top layers of Purdue model, that is level 4 and level 3, level 4, level 5, they are more closer to IT networks, while levels 3 down to 0, these levels, they represent the OT environment where real world physical processes take place. So in simple terms then, the OSI model, it helps IT professionals understand how information travels across networks, The Purdue model helps OT professionals understand how commands and data flow across industrial systems. Commands as in control. So both are the reference models designed to bring clarity, one for the digital world of IT and the other for the physical world of OT. So now that we have understood the Purdue model conceptually, let's see what it looks like in a real world network on the next slide. So on the screen here, I'm showing you the Purdue model that is representing the OT network. Now, unlike the previous diagram where we looked at the different layers of control, that is from enterprise systems all the way down to field devices, this diagram, it goes one step further. It not only shows you these control layers again, but it also introduces something very important. That is the security zones that separate the IT and the OT environments. These zones, they help us define where IT ends and where OT begins. And once you know which layers belong to IT and which belong to OT, you immediately know where you need to place your enforcement boundaries, that is your firewalls, so that any threat originating from the IT network doesn't easily spread onto the OT side. And we will talk about this segmentation and zoning in much more detail later in section 6 when we discuss about network segmentation for OT security. So for now, don't get overwhelmed by all these boxes and layers. Just remember that this diagram is showing you two things together. One, that is the hierarchy of control across Purdue levels. And the second, the security zones that help isolate IT from OT. So starting at the top, you have the enterprise zone. This is your IT environment. This includes, enterprise network where you will typically have corporate systems like email, intranet, or business applications. And then below that, you will have level 4, that is your business planning and logistic network. So this connects to ERP or planning systems that gather production data from the plant. Then in the middle of this, you will have something called industrial DMZ, that is industrial demilitarized zone at level 3.5. And this zone is for this zone acts as a secure buffer zone between your IT and OT. So on the OT side, you will have systems like MES or data historians, or even some SCADA systems that are going to be talking to both IT and OT. So such dual home systems will go into the level 3.5 in industrial DMZ zone. We will talk about this in much detail in the network segmentation slide. So then at level 3, level 2, level 1, level 0, we have already discussed on the previous slide what comes in there. What is important and what is the key takeaway from this slide is that, these two upper layers, they are the IT, and these 4 or 5 layers below, these are the OT. And between them, you should have a firewall that is tightly controlling the traffic flow between IT and OT so that any threats originating from IT side don't spread across the OT side. And then each group of levels, it is contained within its own security zone. So after putting a firewall, you will also create additional security zones that is further segmenting your OT network into multiple zones. So enterprise security zone on the top would be for business systems, IT systems. The industrial DMZ is for the controlled exchange layer. The industrial zone for site and supervisory operations. And then finally the cell area zone, that is where the physical process devices live. And then the idea here by creating these zones is that this is how you should implement network segmentation. So things like firewalls or data diodes to create these zones so that threats from the IT cannot directly impact the operational systems. So you can say that this layered approach, combining functional hierarchy with security zones, this is the foundation of modern OT network architecture. Again, don't worry about memorizing all these layers for now. We will break down these zones and segmentation strategies much in depth in section 6 of this course. For now, just focused on this key takeaway that Purdue model doesn't just describe control layers, but it also helps define where to apply security boundaries between IT and OT networks. That's all on this slide. See you in the next one. So now let's close this section by answering a very important debate. Is the Purdue model still relevant in modern OT security? This is a question that many cybersecurity and automation professionals are asking today. Why? Because the Purdue model was originally developed decades ago, at a time when industrial systems were mostly isolated on-premise and had very little connectivity with IT or the internet. So it worked perfectly in that world because the boundaries between IT and OT were clear and well defined. But today, things look very different. We are seeing IT-OT convergence, where data from machine is being sent to cloud platforms for analytics. We have industrial IoT devices, remote access, edge gateways, and AI-based predictive systems that blur the lines between traditional Purdue layers. So does that make the Purdue model obsolete? In my opinion, not really. Because the Purdue model is still a foundational reference. It continues to serve as the starting point for designing secure architectures and segmenting industrial networks. Even when organizations move toward reference architectures like ISA, IEC 62443, Zero Trust for OT, or cloud integrated frameworks, the Purdue model still acts as a common mental map, a way to understand where data originates, how control flows, and where to place security boundaries. So in short, the Purdue model may not perfectly describe the modern hyper-connected industrial landscape of a smart factory, but it remains highly relevant as a conceptual foundation for network segmentation, risk management, and security zoning. And as we move forward in the course, you will see that when we discuss modern OT security architectures and remote access or cloud data flows, you can still trace many of those ideas back to the principle of the Purdue model. So while the Purdue model might be evolving, its core idea, separating control layers and defining clear trust boundaries, is more important than ever in protecting modern industrial environments. So that's my take on the debate. With that, we end this section. On the next slide, then let's summarize this section and move on to section 4. With that, then we wrap up our section 3. So section 3 was all about understanding the OT environment. First, we started out by discussing about the IT-OT convergence, that how IT-OT convergence makes the network look like a mesh. And then we discussed about IT network design, OSI model. Using that as the foundation, then we jumped on to the OT network design, OT network design's logical view, OT landscape, and the Purdue model, we discussed about it. And finally, we closed the debate of why some consider the Purdue model as non-relevant in today's cloud, IoT, and virtualized control world, OT world. All right, then that's it in section 3. In section 4, we will discuss about IT versus OT security landscape, because both the worlds, IT and OT, have different priorities. That is, IT prioritizes security and OT prioritizes safety. You see a huge difference in the landscape. Things are very different when it comes to security, control, security policies, security governance in the IT and the OT world. We will see how in section 4. That's all on this section. See you in the next one.